converting Cartesian and polar coordinates. Recall in trigonometry, with this diagram, which is form the right triangle, we know the relationship of the right triangle using the Pythagorean as x squared plus y squared equals r squared. And then to form trigonometric functions using this diagram, we can do that as the cosine of the theta is x over r and sine of theta equals y over r, where r is positive. So this way we can rewrite x as r times cosine theta and y as r times sine theta. And now in summary, if the polar coordinates is provided, changing to the Cartesian coordinate by using the formula x equals cosine times uh, x equals r times cosine theta and y equals r times sine theta. Where the Cartesian coordinate is provided, convert to the polar coordinate using the relationship the r, x, and y as r squared equals x squared plus y squared. So then we can take the square root of the sum of the x squared and y squared to get the value r. And recall r always positive. And then to find an angle theta is from the relationship of the x and y. The trig function that form the relationship of x and y is the tangent function. So then to find an angle theta, we can do the inverse tangent of y over x. So we have to work a little bit more when you convert from Cartesian to polar coordinates. Let's see examples. The first one, find the Cartesian coordinates of the points given to be the r equals 2 and the angle theta as pi over 4 for part A. Now we are going to change to the Cartesian coordinates or to the order pair x comma y. X can be found by using the formula x equals r multiplied by cosine theta. And the r is 2, the theta is pi over 4. So 2 times the cosine of pi over 4, which is 2 times square root 2 over 2. Simplify to be square root 2. Now we get the x coordinate. For the y, we use the formula r times sine theta. R is 2, theta is pi over 4. Sine of pi over 4 is 2, square root 2 over 2 as well. And then we get the order pair square root 2 comma square root 2. For the first point. The second point, the r is negative 3 and angle theta is pi. So x equals the r multiplied by cosine theta, which is negative 3 multiplied by cosine of pi. Cosine of pi is negative 1. Now we get the x value as positive 3. The y value can be found by using the formula r times sine theta. R is negative 3 multiplied by sine at pi. Sine at pi is 0. So then the y coordinate is 0. Now we get the coordinate in Cartesian plane as 3, 0. Next example, we are going to find the polar coordinates when angle theta will be greater than or equal to 0, less than 2 pi, and r is non-negative. The Cartesian coordinates provided as x equals 5 times square root 3 for the first one, and y equals 5 for the second coordinates. To get the Now we're gonna find the r and theta to form the polar coordinates. To find the r squared equals x squared plus y squared from the relationship using the Pythagorean theorem. X squared is 5 square root 3 squared. Plus the y, which is 5 squared. Now we get 25 times 3 plus 25 which is 75 plus 25 or 100. R squared is 100, therefore the R is square root of 100 or 10. The R is found. Next, we're going to find theta. The relationship of the x and y for a trig function is from the tangent function. The tangent theta is y over x, and the y value is 5. X value is 5 square root 3. Then an angle, which is simplified to be 1 over square root 3. So then angle theta is from the inverse tangent of 1 over square root 3, which gives us an angle pi over 6. The note for this is, for this case, x positive, y positive. So an angle will be in the first quadrant. So it comes out to be pi over 6 in the first quadrant. So we do not have to modify or change the theta into the appropriate quadrant. So then for this problem, the order pair 5 square root 3 comma 5 converted into the polar coordinate as the R10, and an angle is pi over 6. In this problem, the Cartesian coordinates gives x equals 3 square root 2 and y equals negative 3 square root 2. Note x is positive, y is negative. The order pair x comma y is located in quadrant 4. So an angle theta must be in quadrant 4. And keep in mind the theta will be between, or it could be from 0 to 2 pi. That's what we're going to work on at the end to adjust it if needed. Now we're going to find the R. The relationship of the x, y, and R is x squared plus y squared equals R squared. The x is 3 square root 2. We squared, same as the y value, squared. Then we get 9 times 2, which is 18, plus 18, or 36. R squared equals 36, so R equals square root of 36, which is the value 6. R is done. Next, we're going to find theta. Find an angle theta using the trig function, the tangent theta equals y over x. This problem, the y is negative 3 square root 2, and x is 3 square root 2, simplified to be negative 1. Angle theta is derived from using the inverse trig function or inverse tangent of negative 1. If you use a calculator, you would get negative pi over 4, which is in quadrant 4, but the angle is negative. So this is negative pi over 4 because it goes clockwise. Now we're going to find an angle in the positive form. That means we're going to find the coterminal of an angle negative pi over 4. The coterminal can be found by adding an angle by 2 pi or add another revolution, and it turns out to be 7 pi over 4. So then an angle that we're going to use is 7 pi over 4 to make sure that it's positive and between 0 and 2 pi. Then we can summarize that 3 square root 2, negative 3 square root 2 is converted into the polar coordinate as 6, 7 pi over 4. And it's located in the quadrant number 4, the same as the Cartesian coordinates.